Okay, on to equations of lines, three different forms. So we've got our parametric here. We established that in the first video. We're going to write a vector equation. We're going to talk about Cartesian equations, and then we're also going to talk about another way to write the vector equation here. So first thing, if we have these parametric equations, we can go to a vector equation pretty easily, right? So what we're going to do is take these two, and we're going to call that the sort of starting values. That's going to be your initial point. And then these are the movement in terms of some parameter. And so that's going to be like our slope if we're in 2D or 3D, in this case in 2D. So to write this vector equation in a different form, we're going to say, all right, well, let's let xy could equal 2 and 20, because those are our starting values up here. And then we're going to add to that t times the vector 4, -3. Okay? So this is the original point. This is describing the movement from that original point. Now, we could also write this, if we want to get a little bit more formal, is we can write this vector r as some vector a plus t times a vector b. Okay? This describes where you're starting, and this is the movement from that starting point. Okay, to get the Cartesian, a Cartesian equation involves x and y only. So we're going to have to go back up here and solve for t two different ways, and then set them equal, and then get the Cartesian equation. So the way we're going to do that is, let me just erase this here because it's bothering me a little bit. We're gonna solve for t in both of these cases. So in the top one, that means that t is going to equal x minus 2 over 4. All right. In the bottom equation, t is going to equal y minus 20 over -3. Okay, let me check this because you guys know how my arithmetic is. X minus 2 over 4, that looks right. Y minus 20 over -3, that looks right. Okay, so these are both expressions for t, so they have to equal each other. So I'm going to write that down here. Actually, I lied. I'm going to write that over here, and then we'll write the final product over there. So this means that if this is true, then x minus 2 over 4 has to equal y minus 20 over -3. Okay, if that's the case, then we can say, I'm going to move down here now, that -3 times x minus 2 is equal to 4 times y minus 20. So -3x plus 6 is equal to 4y minus 80. And now if we want to put this in standard form, standard form says have the expressions with expressions with variables on one side, the expression with a constant on the other. So this guy is going to turn into -3x minus 4y is equal to -86. And there we've got an expression for a line. Okay? Not too bad.